So as part of today's class, we are going to discuss about the clustering. Okay, and I have set the agenda that we are going to discuss as part of today's class. Let's see up to what extent we can cover. If anything left, then obviously we'll complete in the next class onwards. Fine. So we'll discuss about the understanding of the clustering, then difference between the classification and clustering, segmentation, types of segmentation, types of clustering and clustering method. So basically 3 to 4 different types of clustering we'll discuss, that is partitioning clustering, hierarchical clustering, density based clustering, distribution model based clustering, distance measure, then different types of classical distance measure, how to measure the distance. We'll use 2 to 3 method, that is Euclidean distance, Manhattan distance, Minkowski distance, okay, Minkowski distance, then Hopkins statistics. Then we'll talk about the Kevin algorithm. Then we'll discuss about the cost function and its important in case of regression problem statement. Then we'll talk about the Hoover loss. Then we'll talk about the cost function for classification problem statement and hinge loss. Then how to optimize with cost function. Then we'll see different example cost function in Python, that is basically MSE for regression. Then how to find the optimal value of K. So what is K and all everything we'll discuss. Then pro and cons of K means, then K mean cluster, K mean plus plus. Okay. So obviously we'll discuss one by one. Let's start with the beginning. The first one, that is understanding clustering. Guys, could you please confirm whether do you have class on May 1st? That is the last Thursday, next to next Thursday, so that we can plan accordingly. Just message me on the chat box if anybody know is confirmed, because that is generally May 1st is holiday, but I just want to know whether do you have any class or not. Because as someone tell in the last class, up to May 2nd you have your class. So May 2nd is Friday, right? So Friday you don't have class. So try to see whether do you have class on May 1st or not. Otherwise, next Thursday will be the last class. Else, we can cover completely if you include the May 1st as the class. Because I need 2 classes. Because as I told you, Naviverse 1 I have not taken. So I want to complete it. But anyhow, any other faculty they have taken, right? That is fine. Okay. So, what is clustering? Guys, try to understand where it stands exactly. Let me write down the machine learning algorithm hierarchy. So this is the entire machine learning universe. As you know, we have divided into mainly 2 parts. One is supervised ML, another one is on supervised machine learning. Now coming to supervised machine learning, again it is divided into 2 different types, that is regression and classification. Similarly, coming to unsupervised machine learning, typically speaking, it is divided into clustering and another one is dimensionality reduction technique. In short, I'm writing dimensionality reduction technique. As part of regression, obviously we have seen like the simple, linear regression, polynomial regression. Okay, all the things. I don't want to make more complex. So let me write down the algorithm that we have covered as part of our class. That is, we have covered two beautiful algorithms. One is simple linear regression. Another one is called multiple linear regression. Similarly, as part of classification, we have covered logistic regression. Clear? So these are the things we have already covered. We have spent a couple of classes. Okay, we have extensively seen how a simple linear regression work, how a multiple linear regression work, how logistic regression work. Okay, we have spent lot more amount of time. Okay, now today we stand here clustering. So as part of today's class and next class, we are extensively see what is clustering and all. And as part of clustering, we are trying to cover two main important algorithm, that is k-means clustering. K-means clustering. Another one is called hierarchical clustering. And obviously, this is part of advanced machine learning, and this is not included at part of your curriculum. That's based upon the keeping semester exam in the mind. Okay, so basically, this is PCA, principal component analysis. Okay, but anyway, we are not going to cover this one. And as part of today's class, I will cover the clustering. I'll give some introduction to K-means clustering. In the next class, we will extensively see K-means clustering along with hierarchical clustering. And along with K-means clustering, I can say there is a elder brother of K-means clustering. Okay, just extension version of K-means clustering, that is K-means plus plus clustering. The same as K-means clustering, but some advantages are there. Okay, that's why it's called K-means plus plus. You think about like some version, let's say Moto, or like Samsung, then Samsung Pro, Samsung plus plus, something like that. So some added advantages, some other extra features they have added. That's it. Okay. So now clear where we stand exactly. We are here today, and will spend today's and the next class. Okay, to learn the entire clustering technique altogether. Clear? Now, guys, why clustering? I mean, what is the basically difference between clustering and classification? Okay, what is the difference between clustering and classification? Classification and clustering. Guys, have you remember in our initial class when I have started the machine learning, I have shown you two beautiful picture to explain the difference between supervised machine learning and unsupervised machine learning. The main difference is basically supervised machine learning work based upon the labeled data set. But here it works on labeled data set. What do you mean by that? Obviously, I will show the same diagram, whatever I have shown to you, just to recall. Okay. Generally, what happens, guys? In case of supervised machine learning, this is unsupervised. Here we know the different classes people in have. For example, just try to recall. I am giving the input data with a label, like for example, elephant, cow, and camel. Have you remembered that diagram? I am training my model. Okay, I am training my model. After that, whenever I'm giving an unknown image that maybe belongs to elephant, cow, or camel, my model will predict that belongs to either elephant, cow, or camel. This is the example of a animal dataset. Similarly, for example, I will take the fruit dataset. For example, orange, apple, and banana. Then, based upon the color, based upon the shape and size, again it will try to distinguish. Okay. So even though I will train to my model. Okay, I will train my model by giving this data set. Whenever I'm giving a unknown data, it may be banana, apple, or orange. My model will predict whether that particular image belongs to, apple, orange, or banana, or elephant, cow, or camel. Getting my point? With labeled. But in case of unsupervised machine learning, guys, what happens? Let's say I'm giving the similar images, but I'm not telling to my model saying that this is elephant, cow, or camel. My model will distinguish based upon the characteristic, that is similarity. This is very, very important. Similarity. Similarity. This word is very, very important for me in today's and next class. What do you mean by similarity? Similarity means based upon, okay, same or similar feature. What do you mean by that? Let's say, for example, this feature includes, this feature includes, it may be color, okay, it may be shape, it may be size, okay, color, shape, size, wide, length, wide, all the things, height, everything. It just include. Clear? Now, based upon the similarity, it will try to bring into a confined area or isolated area and create a cluster altogether. So, whenever I'm telling clustering, that is related to unsupervised machine learning, because I have included here, you can see clustering comes under unsupervised, not comes under supervised. But coming to classification, it comes under supervised. So there is another difference. The major difference is basically classification comes under supervised, but here clustering. It works on top of the labeled data set. It works on top of the unlabeled data set. Clear? So let me show you a beautiful diagram which I have already shown you initial classes. Or this is the first time that you are seeing. If you first time, then maybe you were absent in that class. This is the first class itself I have shown you. Supervised machine learning. What I am doing here, let me maximize it. I am giving a bunch of animal data set. And I'm giving with a label saying that I'm training my model saying that this is belongs to elephant, this is belongs to cow, this picture is belongs to camel. Now my algorithm will learn on top of the training data set. Obviously, this is supervised machine learning. As part of processing, whenever I'm giving some unknown data set, now you can see happily, very beautiful manner is predicted. Okay, this belongs to elephant, this belongs to camel, this belongs to cow. How? The question is how? Because whenever I'm giving this label data set, I'm training my model saying that this picture belongs to elephant, this picture belongs to camel, this picture belongs to cow. It's trying to find the similarity, different features. Okay. The diagram of the animal having long trunk, long teeth, heavy in weight, too much heavy, I mean height, long ear, maybe black in color, that belongs to elephant. If the animal looks like, very tall, long neck, there's a concave shape on the backside of the, that animal, and the color is a sandy color, that animal belongs to camel. If it is not too much tall, not it does not have a long trunk, no long neck, no long ear, not heavy in weight, maybe combination of white and black color, that belongs to cow. That my algorithm learn. So whenever I'm giving any input data set, my model predicts saying that, hey, this image or this animal belongs to elephant, this animal belongs to camel, this animal belongs to cow. Clear? That comes under supervised learning. Now, similarly, same thing, same data set I'm giving to unsupervised learning, guys. What is happening here? See, same input raw data, right? But I'm not labeling it. I'm not telling to my model saying that whether it's a tiger or an elephant or a camel or a cow, I don't know. I'm not telling whether it's a camel or a goat or a sheep or anything else, nothing. I'm not telling whether it's a cow or a goat or a sheep or anything else. I'm not telling. It's unknown output you can see. No training data. Now, at the time of processing, whenever I'm giving the input data in the sense like predicted data, now you can see based upon the similar feature only, my model is just distinguish it to different cluster, but it's not giving name saying that it's elephant or a camel or cow. Are you able to see? Here, create a different classes with label name. It's giving elephant, it's giving the name called camel, it's giving the name called cow. But here, it's not telling anything. Why? Because my model does not know whether this is elephant or a cow or a goat or a tiger or a lion. I don't know. Whether this is camel or something else, I don't know. Whether it's cow or something else, I don't know. But if I give a similar picture like this, it will tell, okay, come and club with this category. Why? Because this looks like a similar feature. Okay, if I give an image having sandy color, long neck, tall, I mean height, kind of concave shape in the backside of that animal, then obviously it looks like comes under the camel category only or cluster only. So here talks about the classes, three different classes. Here talks about cluster. That's the major difference. So guys, now it talks about classes, different classes, labeled classes. It talks about cluster, cluster, clusters. Clear, guys? Any doubts so far? Any doubts so far? Any doubts so far? Now, the next one, that is segmentation. Now, before entering to segmentation, let's try to cover the two things that I have covered in my whiteboard. Let's jump into the PPT and let's see whatever whatever things I have explained in the whiteboard, same things written or anything extra that I looked up. Okay. Now let me quickly jump into my PPT. Yeah, you can see. Understanding clustering. What is clustering? Clustering involves grouping similar objects together based on a measure of similarity. Guys, this word is very, very important. I'll use a lot in today's class and next class. That's what I'm telling. That's what I've highlighted in my whiteboard. Similarity. Clustering involves grouping similar objects together based on a measure of similarity. In clustering, there is no target or outcome variable. Like regression or classification, we have some target variable, right? we have to predict something or it belongs to which classes. But here nothing like that. The objective is to discover interesting pattern, okay, in the data set. The similarity measure is quantified by the distance between two data points. Now you can ask me, sir, if it is an object, like for example, either maybe cow, animal data set or maybe fruit data set, you are telling there are different similarity features we have to consider, maybe shape, size, color, and all. Let's say it's a data point like this, present like this. So, data point, I mean, it's a data, just a point. It does not have color, it does not have shape and size. Then how do I measure? How do I measure the similarity between two data points? The similarity can be measured between two data points by using the distance between them. For example, here you can see the data point which is present in this location, they are very close to each other, compact to each other, compared to this data point area and data point present in this area. That's why I can say these data points are very close to each other, or the distance between these data points is very less compared to the distance between the other data points. That's why I make it one cluster, give a different color for our identification. Let's say blue color. Similarly, look into this data point. These data points are present very close to each other, compact, isolated. So I can say the distance between these two data points is very less compared to the distance between this data point and this data point, or this data point and this data point. That's why I club together, create one cluster, give a different color, let's say green color for our identification purpose. Similarly, for this data point, I am creating another cluster. Now you can see there are three different clusters I have created based upon the similarity between the data point. And how I can predict the similarity between the data point? By measuring the distance between the data point. And how we measure the distance, that is a different story, different topic altogether. We'll cover in today's class. Don't worry. Any doubt so far, guys? Any doubt so far? Now, moving next. Understanding the clustering. Same things, guys, whatever I cover is written here. Classification generally belongs to supervise. That is, an object or an dependent variable is given. But here, clustering generally unsupervised. Classification is generally used for predictive purpose, but clustering generally used for discover a new category, group within a given population of the interest. In classification, specific category are explicitly given, because in our case it's explicitly giving, okay, that is camel, cow, or elephant, three different classes. But in case of clustering, guys, new categories are defined based on the similarity between the instances that are similar to each other are grouped together. Now you can see example, differentiating between cats and dogs. Now, here I have taken some picture of the cat. Here I have taken some picture of the dog. Now I am giving you a model. Whenever I am giving some unknown data set, based upon the similarity feature, my model will predict, okay, these all are belongs to cat only. Now you can see this same image only, correct? Belongs to cat. But in case of clustering, guys, here label data, I am telling this is a cat, these are a dog. But here on label data, I'm not telling to a model saying that whether it's a cat or a dog or elephant or whatever it contains. I don't know literally. Now I'm giving to a model the input data. My model is trained. Now my model will try to segregate two different clusters based upon similarity feature. Because here you can see, let's say one feature I'll consider. Let's say you can see the ear. It's like little bit straightforward. But here it's not straightforward. It's maybe down, top down like this. Okay, and eyes shape different, nose shape different, tail. Let's say dog having long tail or round tail, but cat having long tail, something like this. Different tail. Dog having the height. The dog is a little bit more than the height of the cat, irrespective of the. I mean, I can say age and all. Let's say if you consider a puppies, like basically the kids of the dog, maybe small height, but I'm talking about literally a dog height. Okay, is obviously more than a cat height and all. Clear, guys? Any doubts so far? So this all about the difference between classification and clustering. Okay. Now, what are the area that we use clustering? Guys, clustering has various practical application in different industry. We use almost in all the industry. We use in e-commerce industry. We use in banking industry. We use in marketing research industry. We used in telecom industry as well. Now coming to e-commerce industry. So e-commerce industry basically customer segmentation based on purchase data. Banking industry customer segmentation, you know, tracking credit scoring and analyzing customer profitability. Now, market research, grouping similar item and presenting them to user. Telecom industry, customer segmentation based on market demand and all. So these are the different industry that we use our clustering technique altogether. Clear, guys? Now, the next one, segmentation. What do you mean by segmentation? Now, customer segmentation using clustering algorithm is essential for targeted marketing. Okay, so basically, segmentation and clustering both are the same. We call it as a clustering algorithm. Okay, but that other name is called segmentation altogether. Clustering technique use raw data to form cluster based on the common factor between various data points. In segmentation, various people or product are grouped together on the basis of similarity and differences between them. It's very, very important. I will explain why this point, all this point. For successful segmentation, the segment for must be stable and have inter-segment homogeneity and inter-segment heterogeneity should be there. Okay, let's come back to our whiteboard. Let's try to understand what is talking all about. Fine. Now, segmentation. Yes, what do you mean by segmentation? Basically, we use clustering algorithm. We use clustering algorithm to make it segmented. Okay, let's take an example. Think about, let's say I'm giving the use cases of, let's say, telecom industry. Okay, think about, let's say, Airtel customer or maybe Jio, whatever we make. Okay, now you might have seen, coming to Airtel guys, don't think that the consumer or the customer who are using the Airtel SIM all are same category. How? It's not like that all people are doing recharge once in a year, because you know, right? There are maybe recharge facility of weekly recharge. Few people may be doing weekly means 7 days, like 7 days. Then again they are doing recharge. Maybe few people are doing monthly recharge. Monthly, exact not monthly, it will comes around 28 days, something like that, nearly month. Few people may be doing quarterly recharge, mean for 3 months, maybe it is coming around 84 days, something like this, as I know. Then maybe half yearly, exactly 6 months, something like this coming. I don't know exactly, maybe 6 months. Okay. Then people are doing annually. I mean, just for 1 year they are doing the recharge. Let's say 1 year annually. Guys, based upon this, let's say I consider one small feature. Based upon this, I'll try to segment. I'll make it cluster. Because you know all people's financial condition are not good. Maybe you, if you go for annual recharge, maybe you have to do for 2,999 or something, or maybe 3,240, something like this. So who will spend that this much amount of money? So all people they cannot afford, so they don't prefer to go for annual. For 6 months, maybe it is coming around, let's say 1,290, or maybe 1,499, something like that. Again, it's too much for some of the people. For 3 months, it may be 599, maybe 699, based upon different vendor, different service provider. For 28 days, it may be 299, or be 399, something like this. For let's say 7 days, it may be 49 rupee, or maybe 109, or maybe 89, something like this. So people who cannot afford 1 year recharge or 6 month recharge or 84-day recharge, maybe they can go for 7 days recharge, or maybe at least max to max 1 month recharge altogether. So based upon this recharge capability, I can identify the financial condition of a particular person. Let's say I am to give a bonus voucher, let's say some facility to the people or the customer who are doing one time recharge in a 1 year. Let's say they are going for 2000 to 2999. So people who are doing for 2,999, they are going for 1 year. So I can give something like this. Oh, if you go for another 400 extra, like it will become 2,099 plus 4,000, it will comes around 3,399. Then instead of a 1 year, you will get 1 point, let's say 5 years validity. Then people will really surprise. Oh my God! Just if you go for recharge of extra 400, we are getting 5 month extra. This is a good benefit. But to whom I will give this facility? I will give this facility to the person or the customer who are doing the recharge for annually, just once in a year. I don't want to give this facility to the person who is doing recharge for 7 days or 21 days or 84 days or 6 months. Maybe I'll give some other facility, other benefits altogether. Maybe I will give here benefit. Okay, instead of 49, if you go for another, let's say, I will add, let's say, 69 rupee. So instead of 7 days, you will get for 13 days or maybe 15 days. Okay, or maybe 20 days, I can say. Then you will compare. Okay, 7 days 49 means almost four times I'll do recharge. Means 200, almost nearly 200 rupee I have to spend. But here by spending 69 rupee, I'm covering 20 days. If I spend another 30 rupee, maybe another 10 days I will cover. Almost I'm saving 100. So those kind of benefits I have to give. So how to give? First I have to make it cluster. Cluster is nothing but segment. Because this is one segment. Sorry. This is one segment. This is one segment. This is another segment. This is third segment, fourth segment, and fifth segment. To which segment or to which cluster I want to give the facility, that only I can identify if my data is present in a very beautiful manner, cluster manner, and proper segmentation. That is the benefit of segmentation. If I am not segmented, let's say a total in India, let's say, think about, let's say, 1 crore, or maybe 2.5 crores people are using Airtel SIM, and I am not segmented like this. Do you think that I will give this facility to all the people? No, that's wrong. Because people who are getting 7 days, if I give a facility saying that, hey, if you go for another 400 recharge, then you will get 1.5. That person is not in a position to go for recharge for 1 month, just for 299 or 399. Then how come he or she can afford 400 rupees? Right? Not possible. They cannot afford, then why you are sending the message wasted? They are irritating. If you keep on sending the message, maybe they will irritate and they will try to switch the network from Airtel to maybe Jio or something else, because they will try, see, these people are forcing me to go for higher recharge and all. So that is not a good business strategy. So always your data should be proper segmented, proper cluster. Then only you can focus on targeted customer. Third point is written in the PPT. I told you, right? Targeted customer, targeted, or I can say focused customer. So that how I can identify if my data is properly clustered or segmented. Otherwise, it's very, very difficult. I cannot give the same facility to the entire customer. Clear, guys? Any doubt so far? Yeah. Types of segmentation. Coming to guys types of segmentation, basically it is of three types. Okay, basically it is of three types. One is, let me write down all, then in the PPT only I'll explain. Behavioral segmentation, then the next one is attitudinal segmentation. Attitudinal segmentation, then demographic segmentation. Okay, these are the three major segmentation. So what is behavioral segmentation? Based on actual patterns displayed by the consumer, that is called behavioral segmentation, because in actual pattern it shows the customer behavior or not. Similarly, what is attitudinal segmentation? Based on belief or intent of the people, which may not translate into similar action, that is attitudinal segmentation. And what is demographic segmentation? Based on the profile of a person using information like their age, gender, residential address, locality, income, and all. That is called demographic, which is personal information, I can say, secure information altogether. Clear? That's all about different type of segmentation. Now, let's talk about types of clustering. Okay, types of clustering and clustering method. Fine. Okay, types of clustering and clustering method. Guys, coming to clustering. Okay, so basically it is of two types. Let me write down the clustering types. Clustering. One is called hard clustering. One is called hard clustering. Another one is called soft clustering. Okay, hard clustering and soft clustering. Okay, what do you mean by that? For example, let me take the example. Let's say here is the data side, I mean data point present. Here is the data point present. Let's say here is the data point present. Here is also data point present. Here also data point present. Here also data point present. Here also data point present. Similarly, let me write down the picture like this. Now coming to soft clustering, guys, what happens? Okay, generally, if you compare, looks like this data point, the distance between this data point is same as the distance between this data point and this data point. So I'll make it one cluster. So looks like I'll make it a one cluster. Similarly, the distance with this data point and this data point are close to each other compared to other data points. So I can make it, this one is another cluster. Similarly, the distance between this data point and this data point is same compared to the other, so I'll make it another cluster. So looks like I have created three different cluster by taking just how many points? Let's say 7 points. But here also same thing, 7 points are there, correct? But here what happens? Coming to hard clustering, the name itself is really hard. It's a little bit strict. So it is trying to only cluster the I can say the close data point, not the other data point. So you can see the distance between this data point to data point is smaller than the distance between this data point to this data point or this data point to this data point. Obviously, it is far away, right? So I will make it one cluster. I will not include this one, but here I'm included. That's fine. Similarly, the distance between this data point to this data point is smaller than the distance between this data point to this data point, this data point to this data point. Obviously, these are too far away. So I will make it one cluster. Okay, fantastic. Now I can say the distance between this data point to this data point, this data point to this data point is same. So I'll make it one cluster. But guys, one difference you can see. Here also I'm making three different cluster. Here also I'm making three different cluster. But what is the difference? Difference is that is no overlapping. There is no intersection point in the hard clustering. But in case of soft clustering, there is intersection point. They are overlapping with each other. Are you getting my point? That there is a common data point between, let's say this is cluster 1, this is 2, and this is 3. 1, 2, and 3. There is a common element or common data point between cluster 1 and 2. Similarly, there is a common data point between 2 and 3. But here, no common data point. No common data points. But here, common data points are present. Clear, guys? Any doubts? Any doubts? Okay, now this is a just cluster. Now, what are the different types of clustering? This is based upon the common data point or intersection point. We are telling okay different type of clustering. Now, what are the exactly different types of clustering present? Types of clustering, which I have already written as part of the agenda. I think I no need to write again. Let me scroll up and show you there itself. Guys, there are majorly 4 to 5 different types. Yeah, 4 types. You can see. One is partitioning clustering. Second one is hierarchical clustering. Third one is density based clustering. Fourth one is distributed model clustering. Let's try to jump into my PPT. I will explain there itself directly. What is all this type? And I'll give one example belongs to partitioning clustering, maybe the distribution model based clustering, density based clustering, and all together. Clear, guys? Any doubts so far? Any doubts so far? As I told you, that is partition cluster. Clustering algorithm can be categorized based on their clustering model. Partitioning cluster divides the data set into fixed set of partition or cluster and assign an observation to a cluster based on its proximity to a cluster centroid. K means is an example of partitioning cluster. As I told you, we are going to see extensively in the next class that K mean cluster, which is an example of partitioning cluster. Here you can see I have three data point, I mean a bunch of data sets. As I told you previously, this data point belongs to one cluster that I have highlighted with let's say red color. This data set belongs to let's say blue color. This data set belongs to green color altogether. Now, to implement our Kevin clustering, will come with a different naming convention, or I can say a new technical term that is called centroid. What do you mean by centroid? The point or the data point is present in that cluster, particular cluster, which is present in the center of the data point. That is called centroid. The name itself called centroid. Now you can see randomly I pick some data point and put it as centroid. You can see here highlighted mark centroid, centroid, centroid. But guys, is it really present in the center of the cluster? Let's say this one. Is it present in this edge? This is also present little bit edge. This is also not looks like exactly center of this bunch of data. So what I'm doing, I have to shift. I have to left shift or right shift, off shift, right shift, whatever I have to do. I have to move this centroid just center of the data bunch. You can see here. Red data point present. I move the centroid to inside this. You can see highlighted here. Similarly, for a green color, sorry, blue color, I am putting here. For green color, I am putting here. That's why it is in cluster centroid. Now you can see the centroid present exactly center of the bunch of the data for that particular cluster. So you will get to know more in details in the next class when I will explain about the k-means clustering altogether. Clear, guys? Now the next one is hierarchical clustering. Guys, hierarchical clustering provides a hierarchy of cluster as cluster merge together to form new cluster. And the output is represented in the form of a tree or dendrogram. You can see here. Let me maximize it. All this small diagram or you can box is kind of cluster. This is a small cluster. Let's say 14 to 17 merge with the 13 to 22 cluster. Now it's become little bit bigger. Then again merges with the 12 little bigger. Similarly merges with the 9 to 23 cluster. Now it's become this one. Now merges with 20 to 19 it become this one. Then again come to this blue color. Again it merges small, then bigger, then bigger, bigger. Now this green color and blue color merges and now it becomes a bigger one cluster. Similarly, come to the red color side. Sorry, red color side. Here small, then little bigger, small merges become bigger. Then again now two bigger become this one. Now again two more left hand side, right hand side merges this one, and again it merges to a small cluster that is 11 to 29. Now finally I get this one. So this kind of diagram is called tree or a dendrogram. And basically, we use this terminology in case of hierarchical clustering only. If you see such type of diagram anywhere, that comes under hierarchical clustering, not partitioning clustering. So this is partitioning cluster. This is hierarchical cluster. Now similarly, the third one is density-based clustering. Now density-based clustering segregate various density-based region to form cluster, and DB is an example of density-based cluster. So this is also one of the algorithm which is used for clustering technique. You can see density means where more number of data point or bunch of data point present, it create a different cluster. Now you can see here bunch of data point present, now it create one cluster. Here bunch of data point present, create another cluster. Here bunch of data point present, create another cluster. Now here you can see some bunch of data point present. Now different color notation I'm giving. That is the beauty of DB scan. Happily, because if I show this one, all looks like black and white. You cannot distinguish anything. But if I use a DB scan, it is just modify this diagram into colorful diagram. Okay, this is called density based clustering. Now the last, but now the list is called distribution model based cluster. What do you mean by that? In the 2D axis, let's say this is x and y plane. My data is present in a scattered manner, distributed manner. Now what I'm doing, based upon the density distribution, I'm trying to observe. Now you can see deep black, sorry, red color present this area. Light red color present this area. Now this is bunch of blue color. Now this is green color. Assign an observation to the cluster with the highest probability of having that observation. And EM algorithm is an example of this cluster. I mean, obviously, guys, a lot of algorithm are there. So EM algorithm, that is algorithm name called EM algorithm, like k clustering and hierarchical clustering. We can use EM algorithm for the distribution model altogether. Clear, guys? Any doubts so far? Any doubts so far? Let's come back to my whiteboard. Two important technical term we have seen today. One is called centroid. TROID. What is centroid? Centroid is nothing but one of the data point present at the center center of the data set or the data set or the data points, data sets in that particular cluster. For that, for that particular cluster. Okay, called central. And we have seen there are different algorithms that we can use. Coming to partition clustering, we can use k-mean. K-mean, sorry, k-mean. K means clustering. Okay, let me use a different color. Similarly, for density based, we can use db scan. db scan, SCAN. Similarly, for distribution model based clustering, we can use EM, not ER, EM algorithm. These all are algorithm, came in algorithm, right? Clustering or algorithm. Here, hierarchical clustering or hierarchical algorithm altogether. Okay, clear, guys? Any doubts so far? Any doubts so? If not, then let's move into the next one, that is distance measure. Okay, six, distance measure. Guys, why it is important? As I told you, why distance measure required? Why it is important? Very simple. If it is an object, okay, object. Let's say, for example, anything else. Let's say I'm taking the example of fruits data set, or let's say animal data sets. That's fine, makes sense, because I can find one very important similarity. Okay, based upon different feature. What are those features? That feature maybe shape, maybe size, maybe color. Okay, shape, size include like width, height, length, a lot many things are there. Okay, that's fine, I understood. But if it is a not object, this is just a data set, data point, like data point, then how can I find the similarity between them? To find the similarity between the data point, to find the similarity between data points, we have to take help of distance measurement. Distance measurement means, if let's say here is a data point, here is a data point, here is a data point, or here is a data point, I can say the distance between these two data points is smaller than the distance between this data point to this data point, or this data point to this data point, or this data point to this data point, or this data point to this data point. That's why I will make a cluster saying that these two data point belongs to one cluster. Similarly, the distance between this data point and this data point is smaller than the distance between this data point to this data point, this data point to this data point, and this data point to this data point, and this data point to this data point. That's why distance is very important. Now the time has come. How to measure the distance? To measure the distance, we have two to three beautiful techniques are present. You can see. What are those? Euclidean distance, Manhattan distance, Minkowski distance. Now let's try to see the set point number 7. Different types of classical distance measure. Okay, classical distance measure. Okay, guys. Okay, so let me draw it. Just write down. So as you know, it's three types. One is Euclidean distance. Second one is Manhattan. Third one is, what is that? Third one, Minkowski, right? Minkowski. Minkowski distance. Okay, now let's take a small break. Once we will come back, we'll continue from here onwards. Now, coming to equivalent distance, let's try to see what are the different formula altogether, and I'll explain one by one. By knowingly or unknowingly, out of these three, you have already used one, technique to measure the distance. Maybe your childhood, maybe in the mathematics, but you don't know. Maybe that is called Euclidean distance or Manhattan distance or Minkowski distance. Okay, let me explain. Okay. Guys, have you seen such type of things? I will plot any dot in the 2D axis. Let's say this is my data point. This is another data point. Every data point having two coordinate. One is x coordinate, another one is called y coordinate. Yes or no? Let's say this is x1, y1. This is called x2 and y2. Yes or no? And if I will try to measure the distance, I mean, what is the distance between these two coordinates or through this data point? There is a very simple formula that we know from our childhood that is called, let's say, let me write down here. Uh, let's say distance is equal to, this one, x1 minus x2 square plus y2 minus, or I can say the reverse one, x2 minus x1 square, and does not matter, we are taking the squaring, right? It never comes the negative, that's fine. Y2 minus yn square root over. Have you seen such type of formula in your childhood? I hope definite, because I have learned. Okay, this formula in your childhood, you have learned in mathematics, guys. This is the formula of one of the distance that is called Euclidean distance here. Okay, Euclidean distance. So let me write down here. We call it as Euclidean. So if I want to find out the distance between two different data points by using Euclidean distance, this is the formula I have to use. So what is the x2? This one. What is the x1? This number. Y2, y1. Then square root. That's the Euclidean distance. Clear, guys? Any doubts so far? That is the equivalent distance. Similarly, Manhattan distance is little bit similar to equivalent distance, little bit changes. What is that? Let me write down the short. That is Manhattan distance. So let's say MD. Okay, Manhattan distance. Don't think managing director. Okay. So that is simple. Let's say x2 minus x1. I am taking the modulus because no negative term should come. Then plus y2 minus y1 modulus. Okay, no squaring, no square root. Clear? No squaring, no square root. Clear? Here I am taking squaring, then square root. Okay, here nothing else. This is called Manhattan distance. Let me put in the box. Guys, any doubt so far? It's similar to equivalent distance only. That is Manhattan distance. Okay. Now the third one is Minkowski distance. Okay, let me write down here. So let me use black color. Minkowski SHI SKI, sorry, SKI distance. Here little bit twist is there. What is that? First, what I have to do, I have to take the sum of all the measurement, that is, let's say I is equal to starting from 1 to n. Okay, xi minus yi. Okay, all the data point, not only one data point or two data point. Xi minus yi. I am taking the modulus so that it will avoid the negative term to the power of p. Okay, then whole to the power 1 by p. Okay, this is the formula for Minkowski distance. Guys, clear? Clear? Any doubts so far? These are the different formula that we use to measure, distance between two different data point altogether. Any doubt so far? Any doubt so far? Okay. Now, for the next one, any also with the PPT. Okay. Nothing. Don't worry about that. Then Hopkins statistics. Guys, what is Hopkins statistics and why we use this Hopkins statistics? Okay. Now, guys, whenever we are talking about data point is cluster, because as I told you, right, whenever data point are present, let's say it present very neat and clean manner, okay, fine, we can make it cluster. Sometimes data point is very, present in very, different fashion. You will be surprised which data point you have to include in which cluster. For example, let me take a data point here. Think about it's a kind of matrix kind of things. Okay, guys, tell me, it's clearly visible the distance from this data point to this data point is similar to this data point to this data point. Again, the distance between this data point to this data point is similar to this data point and this data point. All are same. Then how to make it a cluster is very, very difficult. Then in this case, generally what happens, people do prefer to make cluster individual. This is one cluster, this is one cluster. Because if we include this one, then this will shout, hey, why not I will include this point with me? Why not like this? Why you are making like this? Okay, so that's why I am making individual cluster for each and every point. Guys, think about, I'm taking the example only 9 data point are there, but maybe in the real time, think about, let's say here the same distance another data point is there, maybe in the below another data point will come, like this infinite data point I can take. And one more thing, guys, whenever we are doing clustering, always try to remember we are club more than 2 to 3 data point into single cluster. There is no sense, it is totally stupid if I create a single cluster by taking one data point, then what is the sense of creating the cluster? Your cluster means what? Let's say this is cluster. It contains some data point, few data points. That may be 2, 4, 5, whatever it may be. But if I take cluster for each and every data point, then what is the point of creating cluster? That's total stupid, right? Nonsense. So this is not valid. So first of all, before making cluster, we should know whether clusterable, C-L-U-S-T-E-R, clusterable is it possible or not. Whether we can create a cluster by taking the data point or not. Then we'll think about okay, which technique will implement to make it cluster, either k-mean clustering or hierarchical clustering or DB scan or maybe distribution density based clustering, whatever it may be. So how to do that? How to measure that, whether it's clusterable or not, by taking the help of Hopman statistics. So basically, this is a statistical methodology. Okay, by taking the help of Hopman statistics, it will tell us whether we can make cluster by taking those data points or not. How? If there are three different scenarios. If Hopman statistics, I'm taking capital H, denoting by capital H. Okay, Hopman statistics denoted by capital H. If my capital H value is equal to 1, then it is clusterable. Clusterable means we can make it cluster. Now another 2 point. If it is equal to 0.5, which is threshold value, because most of the time it is threshold value, right? If it is h is less than 0.05, sorry 0.5, what will be the scenario? Guys, if it is equal to 0.5, then the data set is uniformly distributed, meaning clustering is unlikely. Clustering not possible. I mean, clustering is unlikely. If it is age is less than 0.5, the data set has a tendency towards uniformity, meaning it might not have a natural cluster structure. Okay, but uniform is present, but here no uniform. What do you mean by uniform? No uniformity. Guys, have you might be remember when I was talking about the Gaussian distribution in the statistics. If my data set follow the Gaussian distribution, means it is present in a normal distribution which follow the Gaussian distribution. This is my positive x-axis. This is my negative x-axis. Okay, and the top one is this one my y-axis, and obviously this is my negative y-axis. Generally, the data point is present, okay, symmetric manner. The number of data point present in the left hand side is same as the number of data point present in the right hand side. This is called uniformity. Uniformity. Here, uniform. But if that is not the case, that is h is equal to 0.5, then in this case it's not uniformity. Maybe right skew, left skew, but it's not uniform. This is called Gaussian distribution. Or normal distribution. Basically, I can say bell shaped curve. Okay, bell shaped curve. Clear? Any doubt so far? Any doubt so far? Okay, let's go to my PPT and I will show you what are things I explained, centering present or not. Okay. So this thing we have covered. Now come to here. Distance measure, as I told you, basically we are using there are three types of distance measure. Okay, classical, correlational based, and edit distance measure. You can see there are three major types of classical distance measure. One is Euclidean distance, Manhattan distance, Minkowski distance. This is the form. Data standardization is a pre-processing step used to convert feature into Z-score with mean 0 and standard deviation to avoid bias towards any one feature. Standardization of data bring all feature to a unitless and common scale altogether. Clear? Now, Hopkins statistics. Apply clustering algorithm for data can result in finding cluster even if the data does not have any meaningful cluster. The process of evaluating data to check whether it is feasible for clustering or not is known as clustering tendency. The Hopkins statistics is used to measure the clustering tendency of data. The Hopkins statistics measure the probability of the data given data being generated using uniform data distribution. If the value of the Hopkins statistics is close to 1, it implies that the data set is clusterable, as I told you. If it is not 1, okay, if it is not 1, if it is equal to 0.5, the data set is uniformly distributed, that is random, meaning cluster is unlikely. But it is less than 0.05, it is towards uniformity, meaning it might not have a natural cluster structure. Now, what is Hopkins statistics? As I told you, Hopkins statistics or Hopkins test is a measure used in cluster analysis to access the clusterability of a dataset. It helps determine whether the data is randomly distributed, that is uniform, or has a meaningful clustering structure altogether. Okay. Now, what are the different use cases? Before applying clustering algorithm, K-means, DB-scan, hierarchical clustering and all, to check if dimensionality reduction or pre-processing is required. To check if dimensionality reduction or pre-processing is required. To avoid applying clustering to dataset that don't have meaningful cluster. Okay. Now, the time has come to see K-mean cluster. Obviously, guys, there is a dedicated session. Our next session will discuss in depth what is K-mean, K-mean plus plus, hierarchical clustering, and all. This is just an introduction part altogether. Okay, what do you mean by K-mean clustering? Okay, as I told you, let me come back to my whiteboard. So this one completed. Let me put tick mark for all the things I have completed. K-mean clustering. Okay, as I told you, as part of 1 minute. Yeah, as part of today's session, where is the hierarchical diagram? Yeah, as part of clustering, we are going to cover two important algorithms altogether. One is k-means clustering, another is hierarchical clustering. These two things we will discuss extensively in the next class. So coming to k-means, basically, obviously a lot of other steps are there. I'm just giving some highlight key point, and next class we'll discuss. Okay. Coming to k-mean clustering, guys, what happens? The process is basically okay. K means number of cluster. Okay, I have to take number of cluster initially. Then I will follow certain steps. It should be repeated step. Then I'll see whether the number of cluster that I've taken that is correct or not. I have to change based upon that. Okay, it may be, and for that we are using elbow method and all. Lot of things are there. We'll discuss in the next class. Nothing to be worried. Okay, and I'll go to my PPT. I'll explain what is this K mean clustering altogether. Let me come back to my PPT. What are those steps? Now you can see. K-mean is a popular partitioning clustering algorithm. As I told you, there are four different type of clustering algorithm we have seen: partitioning clustering, then density-based clustering, hierarchical clustering, then distribution model-based clustering. Now coming to K-mean clustering, it comes under partitioning clustering altogether. Understanding centroid is crucial for understanding the K-mean clustering because that is very very important. Very very important. Centroid are the center point of the cluster. Yeah, it's written clearly, which I have already written in my whiteboard. That are being formed and are calculated as a mean of all observation in a cluster, in that particular cluster. Okay. K-means is a centroid based algorithm where each cluster is associated with a centroid and the distance between data point and cluster centroid decides membership altogether. Now, the K-mean algorithm involves two important steps. First one is assignment step, second one is optimization step. What is that assignment step? Under assignment step, what we are doing, each observation to the closest cluster centroid, while the optimization step update each centroid to the mean of the point assigned to it. To use the algorithm, you need to state the number of cluster, that is k, that will be present in the result. You have to take initially maybe 4 cluster, 5 cluster, 7 cluster, whatever it may be. The algorithm select k object randomly as initial cluster center and assign remaining objects to their closest centroid altogether. Now, K-mean algorithm. The algorithm calculates the mean value of the cluster and reassign the object to centroid accordingly. The algorithm repeats this step until the assigning cluster stop. The K-mean algorithm has covered if the assignment of point to cluster centroid in the last two consequent iterations are the same. Okay. Now, obviously, in the next class, we'll see in depth. Okay. Once I show the practical, you will get to this. Now, the time has come to see cost function. Okay. Let me scroll off. Okay. Guys, what do you mean by cost function? This thing you know already. Okay. Generally, have you remember the error term we are talking about? The error term. We calculated the difference between the actual value and predicted value. Remember? Predicted value. Predicted value, and this is actual value. This is called our error term. Yes, you know already this thing. Now this error term typically we call it as loss function, loss, or sometimes you call it as cost function also. Cost function. It's a loss function or loss or cost function altogether. Now coming to cost function, what is important? Because based upon the cost function, and one more thing, as I told you, the error is nothing but the difference between actual value and predicted value. The lower the cost function value, I can say, higher is the performance of the model. Performance of the model. Performance of the model. Okay. Performance of the model. Clear? Now, how it is very very important because it plays a very important role to decide which particular algorithm we have to use at what point. Now coming to cost function, and it's important. Cost function. Okay. We can implement, okay, in almost different scenario. Like for regression problem statement, in short I'm writing PS. For classification problem statement altogether. Now coming to regression problem statement, what are the cost function we can use? Simply let me write in the example. That is first one is MAC, mean square error. Mean square error. Then second one is MAE, mean absolute error. Now there is a combination of okay MACE plus MAE. If I don't want to take individually, I want to take combination of both. Then that term is called okay beautiful term that is called Hoover loss. Okay, that is called Hoover loss. Okay, HUBER Hoover loss. Similarly, coming to classification, guys. Coming to classification, we have something called binary cross entropy. Okay, we have something called binary cross entropy. Okay, then we have something called categorical cross entropy. Cross entropy, and sometimes the binary cross entropy also we call it as log loss. Log loss. Okay, log loss, and this is categorical cross entropy. And binary cross entropy we used for binary classification. Binary classification. And categorical cross entropy we used for multi-class classification. Clear? Binary classification and multi-class classification altogether. Now, as we have something called Hoover loss. Similarly, there is something another loss is called hinge loss. Hinge loss, which we use generally in support vector machine. It's an advanced machine learning technique altogether. The combination of all other loss, small loss. So this is hinge loss altogether. Clear, guys? So that's what I have already clearly mentioned in my agenda altogether. Yeah. So Hoover loss, hinge loss. So coming to regression, we have something called MAE, MAC. Okay. And coming to classification, we have binary cross entropy, and we have something called categorical, right? Categorical cross entropy. Clear? Okay. Now hinge loss we have covered. Now let's try to see how to optimize optimization with the cost function, and I'll show you some example. Okay, with this we'll cover these two things. Okay, so let me go back to my PPT. I'll show you certain formula also for this, how we are calculating all this. Okay, how we are calculating MSc. Okay, how we are calculating MSc, how we are calculating MAE. Okay, all this formula I'll show you. Okay, over loss. Sure, fine. Let me come back to my PPT. Mean square error, MAC, that is nothing but the difference between the actual value and predicted value square. I'm taking mean. Mean means what? That average, right? I'm taking 1 by n. Okay, it uses in linear regression. penalizes large error more than small error. Now mean absolute error 1 by n, again mean present means 1 by n. Now absolute means what? Just absolute, not squaring. Difference between actual value and the predicted value, just mean. And less sensitive to outlier than MSC. Okay. Now similarly, Hoover loss, combination of both MSC and ME. Used for robust regression to handle outlier. Similarly, for classification, we use binary cross entropy, which is called as log loss. And we use this for binary classification, that is logistic regression, as we have already learned. Okay. Now coming to categorical cross entropy, it is used for multi-class classification. Okay, no need to remember the formula, just have a look. Okay. Nobody will ask, tell me the formula. Okay. Now here's the loss. So minimum value is 0, maximum value will be 1 minus multiplication of actual value and the predicted value, which is used for support vector machine, which is advanced machine learning technique altogether. Clear guys? Now optimization with cost function. To minimize the cost function, because as I told you, if we minimize the cost function, the performance of the model will be increased. So our intention should be always to minimize the cost function altogether. Clear guys? We use an algorithm like gradient descent, iteratively adjust model parameter, which already we have learned before. Gradient descent computes the derivative of the cost function and update the parameter in the direction of decreasing loss. Similarly, we use some optimizer technique like Adam optimizer, boosting technique and all. An advanced method that adopts learning rate for faster coverage and all. Now some example you can see. Okay, I have taken a numpy array. Okay, so I have taken 3 minus 0.527, 2.5028. Okay, I'm trying to find the mean value. The model aims to minimize this MAC to improve the prediction. So if you see the output, you can see optimal K. How? Obviously, we will discuss in the next class. So I'm trying to draw the diagram in between the number of K, there is nothing but the assumption that number of centroid and WCSS within cluster sum of square. What is sum of square? Have you remember we have already studied RSS, residual sum of error, TSS, total sum of error. Already we have covered. Okay. And how we are finding that RSS is nothing but U1 square plus U2 square plus E3 square up to En square. And how we find that U1 square? U1 square is nothing but the difference between actual value and predicted value square. I mean Y actual minus Y predicted square. Everything we are discussing, our last session all together. Okay, just have a revision, you will get to know each and everything. Now choose the value of K at which the core begins flatten this point. Elbow method, this elbow point I told you, right? At what point it touches the elbow point, we'll learn in the next class. That is called the number of K, or the number of centroid and number of cluster. Okay, we use that method called Chidong method. Okay, so this is the formula, no need to remember, you can see. As these data points are very close to each other, I'm making one cluster. As this data point is far away from this point, so I'm making into another cluster, not belongs to this one. Okay, this thing already we have discussed extensively in my whiteboard. Okay. So elbow method is a decision rule, whereas the Shillong method is the clustering rule altogether. Now, what is the pro and cons of K-means? That's why K-mean plus plus come into the picture, right? Similarly, like different latest version in the mobile phone, like suppose let's say some version come into the, you can see the plus plus or a pro version come, means some added advantage or feature they have added, right? Pro, what is the advantages? Simple to implement compared to the other clustering algorithm, scalable for both large and small scale data set, guaranteed coverage, covariance, after a number of iteration, convergence, right? Cost function reaches its minimum at convergence. Okay. Now, what is the disadvantage of K-mean? Choosing the best K manually, because randomly you have to choose, then you have to validate it. Okay. K-means work best mainly for spherical shaped cluster, highly dependent on initial centroid. Outlier has a serious impact on performance, cannot be used with categorical data. Distance-based measure converts with increasing dimension altogether. That's why K-mean plus plus, which is the elder brother of K-mean, come into the picture. Guys, Any doubt so far? Any cluster algorithm? Okay. Okay. K-mean plus. Guys, any doubt so far? Let me see your chat box. Told you K means plus plus is a kind of think about elder brother or elder sister or K mean. There are little bit disadvantages are there in K mean which we overcome by using the K mean plus plus. K means is sensitive to centered initialization which can result in a poor clustering. K means plus plus algorithm is a type of centered initialization that select initial centered that are far apart from each other. K means plus plus is the default initialization technique for the scale-on implementation of K means. The disadvantages of K means plus plus is that calculating the farthest point will be expensive. So initialization is carried out on a subset of the data set. Even though we overcome the problem that will occur in k-means, but there is some disadvantage also there in k-means plus plus. Okay, now you can see how it works. K-means plus plus algorithm goes as follows. One center as one of the data point at random. For each data point, let's say x underscore I, compute the distance between x underscore I and the nearest center that has already been chosen. Now choose the next cluster center using the weighted probability distribution where a point x is chosen with the probability proportional to derivative of x square basically. Repeat step 2 and step 3 this thing until k center has been chosen. So this thing will be 100% clear in the next class onwards whenever I will cover the k mean. Okay, yeah, so that is no further slide. I can say that is the end of the gaming process. Yeah. So we have completed gaming process, obviously the introduction. So with this, I think nothing is pending, right? We have successfully covered all the agenda, the topic that I have said for today's class. Okay, yeah, gaming process, everything successfully have completed. Okay. So in the next class, we'll talk about K means clustering and hierarchical clustering.